My name is Dr. Nyachieo. I'm the director at the Institute of Primate Research. This is a biomedical primate center that was set up to develop drugs, vaccines, and medical interventions for diseases, health conditions, and challenges that affect humans. We are WHO collaborating center, and we are also accredited to the American standards, and that means that our research agenda receives endorsement at the highest level. As we observe the World Malaria Day, I would like just to mention something about malaria because this is one of the programs that we have been researching here. And I want to start by saying that almost half of the global population is at risk of contracting malaria. In 2020, for example, over 600,000 deaths were reported globally. In Kenya, for example, 3 million people get infected with malaria, with over 10,000 people dying annually due to malaria infections. As an institution, we have developed baboon as a model to study this disease. We have in particular even developed and tested some of the natural products, which we hope that will be used in terms of management of the disease.
Today, as we are marking the Malaria Day, we have to note that malaria is a challenge to us and to the people. And out of the data that we have, the higher prevalence of the disease is actually in the developing country. For example, the same year, the prevalence of the malaria in Africa alone was above 95%. The same applies to the deaths. So that means Africa, we are suffering from the burden of malaria. And since we are researchers here at the Institute of Primate Research, our role actually is to do epidemiological study, to look at the prevalence of this disease in the country so that we can inform policy. In Kenya, we also know that in some areas we have co-infections where malaria coexists with other infections, for example, malaria and schistosomiasis, malaria and leishmaniasis, for instance. In these areas, the burden of the disease or the burden of the co-infection has also informed on what kind of drugs that are being used. And in terms of disease resistance or resistance of the parasite itself, we know that there is always emerging resistance due to the drugs that are available. Therefore, we as researchers, we are making efforts together with other researchers in the world to be able to reduce the malaria burden by 90% as it is stipulated in today's day that we are marking Malaria Day.
The malaria program in the Institute of Primate Research was started around 1998. The aim was to develop a preclinical system for malaria research into vaccine and drug development. But in the process, we also developed an area of understanding parasite biology, that is the malaria parasite Plasmodium. And the next key achievement was developing the baboon model for preclinical research in malaria. And lately, we added natural products development, whereby the aim of the natural products program is to undertake scientific validation of natural products as a way of developing new interventions against malaria. We realize that drug resistance against malaria is rapidly developing. Resistance against artemisinin, which is the first-line drug, has developed in Asia, and it would soon come to Africa if we stop research into further drugs that can take over. We will be doomed, and natural products becomes a key area. Malaria program at the Institute of Primate Research has developed a few lines using natural products from Buga ugandensis, from Xanthoxylum osambarensis, Ajuga remota, and the Senna occidentalis. So we are undertaking scientific validation of these products, natural products, which are used in traditional medicine healthcare against malaria. So our aim, we have demonstrated in vitro that they are effective against Plasmodium. We have gone further to show that in vivo in mice using the mouse malaria Plasmodium bergeri. And further, we are undertaking preclinical development in baboons using the baboon model. At the end of the day, our aim of scientific validation is to confirm that indeed these plants are effective against malaria, which we have. And the next is to develop a way forward that they can be safely available to the population. One approach is available as is, whereby they can be registered as food supplement. Then the other one is to further develop the pharmaceutical pipeline, which would end up with the drugs that are derived from these products, either on their own or synergized with other products.
Malaria, being a public health problem, affects children under 5 and pregnant women, who are the most vulnerable in the population against this disease. Small children, because they are yet to develop immunity against malaria, and pregnant women are predisposed because there is a shift in the immune system in order to allow the fetal allograft and the placenta. Severity of the disease varies with many factors, and one of them is transmission patterns. On the other hand, in areas of moderate transmission rates, women in all levels of pregnancy are at risk. So whether they're in their first pregnancy or in their multiple pregnancies, they're equally at risk. Malaria during pregnancy is associated with adverse pregnancy outcomes, which include low birth weight, intrauterine growth retardation, stillbirth, abortion, and pregnancy-related anemia. As serious as the subject of malaria during pregnancy is, there is still a very huge gap in understanding the mechanism of this condition. For example, the gold standard method of diagnosing malaria during pregnancy is histopathology, which requires examination of placental tissues that are only obtained after birth. Other factors such as inadequate tissue for analysis and lack of appropriate animal models have contributed to progression in this area of research.
There is still little information on the safety and effectiveness of treatment of malaria during pregnancy due to lack of information on the effect of these drugs on the development of the fetus. The development of new drug molecules is not only time-consuming, but a challenging process in the current era. A promising and a novel strategy to overcome these challenges is to reformulate the already existing anti-malarial drugs through nanomedicine for placental malaria treatment. Nanoformulations enhance properties of conventional drugs, and by targeting specific delivery site, which is the placenta in the case of malaria in pregnancy.
Co-infection is a state in which a person or a host is infected with more than one parasite at a given time. Globally, co-infections are the norm rather than the alternative, and they are known to alter disease outcome. When it comes to malaria co-infections, they are actually very common in endemic areas, and depending on the interaction of the parasites and the host, they can either be detrimental, they can be insignificant, or even at times they can actually be beneficial. Examples of detrimental interactions are when you have malaria and HIV, or when you have something like malaria and TB. Of equal importance are malaria and helminth infections, co-infections. Helminths are known to be chronic in nature, and they're also known to significantly alter the immune system of the host and subsequently alter disease progression and also disease outcome. Results from our studies have shown that co-infected animals are protected from severe malaria, and actually we see that they're protected from clinical malaria, they're protected from high parasite burden, and also have less anemia. And though these results are very beneficial to the host, but on the other hand, we can see that when you have low levels of circulating malaria parasites, this can actually have an impact on control strategies to malaria and also elimination of malaria. And this is because such persons can become host reservoirs and also help in propagating the spread of the disease. Our studies have also shown that co-infected animals also have an altered immune system, especially when it comes to acquired immune responses to malaria infection. And this might actually have an influence in long-term protection to malaria infection and also to vaccine efficacy.
We already have promising results in mice, and we are now currently working on a higher animal model, that is the baboon model, where we are using this nanoformulation in the treatment of malaria during pregnancy. These results will inform future trials in humans.
Baboons are ideal for this kind of study because of their size. They're relatively large and sampling them is easy. They also have a host pathogen interaction that is phylogenetically close to humans. The reproductive cycle is 28 days, which is very comparable to humans, and this is very important for the kind of research that we do because it allows us to do synchronized time mating that enables us to estimate the gestation periods of the baboon models that we're using in our research.
At IPR, we have studies that are looking at the chronic nature of schistosomiasis, which is a helminth infection, looking at how that will affect malaria, severity of malaria. And in these studies, we have actually used the baboon as a model of infection. And the baboon is a good model of infection because they are naturally and also experimentally infected with schistosomiasis and also with P. nosai, which is also a malaria pathogen and has recently been recognized as a fifth pathogen that infects humans.
The gains made in the fight against malaria were greatly hampered by the COVID-19 pandemic. This led to reduction in funding. In certain areas, we saw emergence of resistance to both the drug and insecticides. And overall, there were concerns that, if we've gotten to such a point at controlling the malaria disease, this could be affected. So we at IPR, a number of scientists at IPR, are committed to fight the malaria disease. And there are a number of projects ongoing within the Department of Tropical Infectious Diseases. But from my point of view, now that we know that the malaria parasite genome has been fully sequenced, we are now taking advantage of this particular area to see if we can design a malaria diagnostic tool. And the approach we're using is based on the LAMP method, and we are fortunate enough to have secured some funding from NIHR based in the UK through the Royal Society for Tropical Medicine and Hygiene. And the student who received this grant will be looking at designing a robust, simple diagnostic tool where we're basically targeting a specific gene within the malaria parasite. With this particular application, we hope to be able to evaluate it in the lab initially. And then once we know how effective it is, we'll be able to roll it out in the field, having tested some samples, both urine, blood, and saliva, just to check on the sensitivity. So we hope to contribute to the fight against malaria through designing effective diagnostic tools, which will have implications when we look at scenarios where you've got very low parasite density and you need a very sensitive and robust tool that can detect parasites. So the idea for me would be to save lives and give people, young children, a chance to live. That's young children, mothers who are also greatly affected by the disease, better protected, and basically improved healthcare to the society at large.
As we mark this World Malaria Day, we have a hope that in the near future we'll be able to safely and effectively treat malaria during pregnancy.
As we mark World Malaria Day, I hope there'll be more sensitization on the role of malaria co-infections on health outcome and control strategies.
As we mark World Malaria Day, that has a theme of innovation. The hope is that we do not stop innovation in drug development, including natural products. We should also go further to consider drug repurposing so that innovation can always put us a step ahead of the parasites from a drug point of view, even as we work to eradicate malaria.